All right, for this next radical rule that you need to make sure you are familiar with and understand the steps to help you problem solve with is dealing with multiplying and dividing. And the phrase that pays is understanding when dealing with this operation, inside to inside, outside to outside. Okay, memorize this. Sing it to yourself. Rap it to yourself. Reggaeton to it yourself if you have to, but make sure you understand inside to inside, outside to outside. What I like to also help you recognize is that inmates and outmates do not mix. Inmates and outmates do not mix, and I'll show you and explain that to you on some of these examples. Your first step when multiplying or dividing is you're going to multiply the outside number together and then multiply the inside numbers together. So I'm saying you do not mix them. Keep the two parts of the answer separated. Outside numbers go together, inside numbers will go together. And then always make sure you simplify the final answer if needed. Now, when I'm talking about inmates and outmates, your inmate is your radicand. That's your number inside or underneath the radical symbol. And your outmate is your coefficient. Now, in this first example, we have nothing but inmates, meaning the two radicands are 2 and 8, so they stay inside the radical. So 2 times 8 is 16, and the square root of 16 is 4, because it's a perfect square. So that's your final simplified answer. Here, we have the square root of 3 times 2, square root of 3 times square root of 2, which is just the square root of 6. Okay, square root of 6. Now, the square root of 5 squared. This exponent here, this is your exponent, tells you you have two factors of the radical 5. So basically I have the square root of 5 times the square root of 5. This is two factors. Okay. So this is a special thing that happens whenever you take the square of a radical. Well, let's watch. Square root of 5 times the square root of 5 is the square root of 25. And what's the square root of 25? It's 5. You could have had the square root of 225, 235. The minute I square it, I'm basically taking the inverse or getting rid of the radical, because anything times itself underneath the radical is just going to be what's underneath the radical. That's just an extra, it's just going to be your radicand. So, now, inmates and outmates do not mix. 26 is a good example of that, sorry. So, outside stays together, inside stays together. So, outside is 3 and 2. So, the 3 and the 2 get multiplied together. Inside is the 6 and the 3. The 6 and the 3 get multiplied together. So we would have 6 times the square root of 18. Well, the square root of 18 can be simplified, remember, because we can't have a perfect square as a factor left inside the radical as part of the radicand. So this would be 6 square root of 9 times 2, because 9 times 2 would give me 18, and 9 is a perfect square. So that would give me 6 times 3 square root of 2, which is really just 18 square root of 2. Okay, so you are still going to have to simplify after you multiply if the radicand can be broken down as another perfect square. So now, this one has a coefficient, the 7. It's a little different. But we're going to square the whole term, 7 square root of 3. Meaning you're going to square what's on the outside, and you're going to square the radical 3. Well, 7 squared is 49. And whenever you square a radical, you get rid of the radical. So this is 49 times 3, which is 147. And then what we have is same problem type here. 2 square root of 2. We're taking that term and we're squaring it. So hopefully, if you understand what's going on, you put the exponent of 2 to each term, what's on the outside and to what's on the inside. And hopefully, if you work this out, you get 8. Okay. Now, I want you to try to work 23 through 25. I'm going to check those in class. What I want us to discuss will be, not 23, sorry, 29 through 31. You're going to work on. What I want us to discuss is 32 to 34. These problems are just like using your distributive property or the full method, because you still have two. Well, this one you have a monomial times a binomial. This is one term times two terms. And so you're going to distribute to each term. So we would have the square root of 6 times 5. So leave you with 5 square root of 6 minus the square root of 6 times, well, I can write it, the square root of 6 times the square root of 6. Well, this is like saying the square root of 6 squared. So 5 square root of 6 minus 6. And this is a simplified answer, because we saw on adding and subtracting, you can only add if they have like terms, which means the same radicand. This only has one radicand of 6, and the other one does not. So we are done on here. Now in 33, this is where I was talking about you have your full method. This is the same method we used last semester. You're going to do the first. So we're going to do 6 times 5. And then you're going to do the outer, which is 6 times the negative 3, or the square root of 3, excuse me. And then we're going to do the inner, which is the square root of 3 times 5. And then the last, which would be square root of 3, because it's minus, square root of 3 times the square root of 3. All right, so we're just going to do some simplifying, and I can just rewrite this. But we have 30 minus 6 square root of 3 plus 5 square root of 3 minus 3. Because whenever you multiply the radical times itself, it's just going to leave with the radicand. So I can add my like terms. The like terms here that I have are the 30 minus the 3. And then I have the negative 6 radical 3 plus 5 radical 3. Now these I can add together because they have the same radicand. So I'm going to be left with 27, and this is going to be with the negative square root of 3. And that's my final answer. It is possible to have a final answer with 2 different terms that cannot be simplified any further. So on 34, using that same method, I'm just going to multiply first in the outer. So we're going to have 40 plus 5 radical 10. And we're going to do our inner and last. So plus 8 radical 10. And then plus 10. So that's going to leave me with 50 plus 13 radical 10. All right, so I'm hoping identify and recognize this rule with multiplying inmates and outmates don't mix will help you with your simplifying. Now, when it comes to dividing, which is what we have on 36, remember inmates and outmates don't mix. So on here, 7 is inside and 5 are inside. They are both inmates. Can 7 go into 35? And I said 5. Can 7 go into 35? Yes. 35 divided by 7 is square root, or is 5, so the 5 will stay inside since they were both inside. Now, 3 is an outside, so I don't do anything to that. It stays outside. But I look at the 7 and the 21. They're both inside, so I can work with those two numbers. 21, the square root of 21 divided by the square root of 7. 7 is divisible by 21, which is 3. So the 3 will stay outside. And then the other 3, 21 divided by 7, 3 will stay inside. Now, here, both are inside, the 2 and the 32. This is like a fraction. 2 over 32 can be reduced to 1 over the square root of 16. Now, we know what the square root of 1 is. Square root of 1 is 1. So now I'm just left with 2 times 1, which is 2, over the square root of 16, which we can also work out. Square root of 16 is 4. So 2 over 4 can be reduced to 1/2. So 5 can go into 40 because they're both inmates or inside. 5 can go to 40 8 times. So we got square root of 8 over 10. Now, we can't stop there because we know square root of 8 can be simplified to 4 times 2. So we keep the 10 at the bottom. We break down the 4 and the 2. 4 is the perfect square. So you're going to be like 2 square root of 2 over 10. Now, as soon as I bring that 2 out, this is now outside. This is an outmate, and this is also outside. So I can look at 2 over 10 as a fraction and reduce that to 1/5. This can also be written as just the square root of 2 over 5. So either way would work. So I'm hoping that helps you get a better understanding of multiplying and dividing. The next video will be over rationalizing. And that is a little tedious if you just understand that there can never be any radicals at the bottom. So please check out the next video for the remainder of your notes and be prepared for tomorrow.